Okay. I will be glad to give you all some glimpses of what's going on in the experiments, so the point of view of the challengers. My name is Federico Vicentini. I'm with the National Research Council in Italy, an institute which is dedicated to factory automation, production, robotics, and so on. We're part of the EFRA platform and many other research groups in Europe on the field of reconfigurable manufacturing, human-robot interaction, and so forth. That is why we concentrated on a problem arised by one of our main partners in is SME, providing tool machine centers. So it's integrated is a machine tool builder which is providing flexible manufacturing systems, which is based in northern Italy. What you see in the picture is an example of a fairly large plant with a number of CNC machines, transporters, all automations dedicated to flexible manufacturing, with one manual task left to the operator, which is the assembly of the fixtures and jigs and tool workpieces before the pallet entering machines. This is taken care of by the most skilled people in the company, being a very critical step in production, in automated production, because any error is worth the long downtime, and cost you to damages to the machine or to the workpieces and so forth. So we went there and we tested. We were trained in one day in trying to do this task. It was pretty nice to have to share the experience with the end user, which is day by day taking care of this hard task, which is hard from the point of view of ergonomics, and from the point of view of the mental workload, because they must be sure that the assembly is okay before entering the machines. So our main purpose was to have an entire experiment dedicated to the assembly of this task, helped by the robot partner. So we see the human-robot cooperation as a main tool to develop technology, useful technology in all those domains that which are, say, part of manual tasks, which are not going to be replaced, but assisted by the robots. This is a big hot topic, a replacement of jobs, automation, how automation can help manufacturing. And in this case, I must say that this is one case of useful assistance of robot, not replacing, but helping very much the core tasks. So our objectives were ergonomics and, more importantly, error limitation before entering. So this was a problem. The solution was to use this kind of human-robot shared environment or reconfiguration. I see most of the keywords well spread around. And the point is that using robot technology, the user is free to prepare the workflow of operation which most fits the requirements in terms of ergonomics, usability, and runtime planning, because the operator is free to choose whichever sequence need to be done for the most effective production plan. The solution is a robotic assistant in the larger domain of the smart factory, able to do the number of good tasks that a robot assistant can do, which are the most repetitive, the large weight carrying, and so forth, with the most important features summarized as fast interaction control, sensing the human presence, because it's very important to know and to guess where the operator is going to be and what he's going to do, for planning motions and tasks for the robot assistant in a due course. Due course means safely and in a usable way. That is why also task programming, which is a very hot topic in the last decade in robotics, is taking off in the real environments as the one which have that we have at hand. And here, the framework of Euroc project comes very helpful, because it's goal-oriented, and we have the chance to bring innovation and integration of, say, well-known and well-established robot technologies in an effective way, in a robust way. What we believe is important is to have those technologies, which are extremely popular in the community, to be reliably delivered to end users. And the challenge proved to be a very effective platform where to trade ourselves and together with our peer challengers, so to first make our, say, community level engagement in the manufacturing task. You see here in the movie the benchmarking phase that Fabrizio was mentioning before. All the teams were dedicated to the single task, a single performance task, challenging each other who was the best performing this car door assembly with vision, force interaction tasks, human-robot interaction, gestures, and whatever. So the task was completed by all the teams with different scores depending on the quality of the outcome. Collaborative robotics was the main task where to confront ourselves and to move on in the freestyle and the showcase steps following the first one. Collaborative robotics is an opportunity, and as I said before, this kind of task will benefit very much for the cooperative technologies, and especially the end users in this domain. The impact, what is the main impact? First of all, we in the manufacturing have a two steps structure for our end users. We have machine tool builders who are going to, and are usually not that large companies, and we have the higher concentration in Northern Italy of machine tool builders, one of the biggest association in Sesimo, for example, which are in charge of delivering systems, production systems, and who are the best candidates for taking over these kind of technologies and embedding into the offer of machine tool machine tools. Then we have the second level of end users, which are actually the customers of machine tool builders, which are the machine tool users. So we have a leverage effect of the potential usage and penetration of the main benefits of human-robot cooperation technologies in manufacturing. So the main benefits, if we want to measure and to have some metrics of the economic benefit, using this scale-up effect of a double-step end usership, we might have the effect of reducing errors. So computing, for example, a reduction rate of errors by 75%, as in the slide, a number of events related to damages or downtimes or all the stuff like that which are, of course, very limited during the year, and this is a conservative estimate. The entity of damage conservatively reduced to 1,000 euros per event. We might have a good savings in terms of millions at continental level because of the assistance of the robots. So robots are going to do whatever they are good at, while humans are continuing to do what they are good at. So checking, planning, taking care of the most difficult dexterous manipulation task, while the robots could be the ones who are in charge of checking, testing, inspecting, and formalizing all the production plan in terms of errors. So this was the impact, and we believe, and our end users partners are very happy. And in the end, the plan is to have this technology, the small cell assisted by the robots, permanently part of their facilities, and specifically the system integrators is going to have a permanent teaching factory for showing the second level customers how to promote human-robot cooperation technologies in the larger domain of automation, manufacturing, and machine tools. So thank you for your attention. This was a first glimpse of the manufacturing challenge, and I leave my stage to Vlad for flying robots.